Hey there, and welcome to this video. My name is Chris Noring. I work at Microsoft. In this video, we'll cover generative AI with JavaScript. So what we'll go through is the Azure tools that you will most likely need, and also the different Azure services that make sense to use together with your AI so that you end up hosting and storing your AI apps. Let's look at the agenda for this video and this presentation here today. First off, we'll look into AI apps, what those are, what different types of AI apps that you can build, because there is more than one. Then we'll talk about tooling and how our recommendation is a CLI tool here called Azure Developer CLI or ACD. We'll also discuss architecture because there are a few different choices. We will go through container-based and serverless, and we're not going to have a strong opinion each way, but more explain where one of them may or may not fit your needs. Then we'll talk about how we can manage APIs in production, because getting them into production is great, but you need to keep track of them for the sake of cost, for the sake of fair usage, scaling, security, and a lot of other things. But we will explain that as part of this video. So let's have a look and discuss AI apps, because there are three major apps that you could be building as an application developer. Either you are building a chat app, in which case you are integrating OpenAI, or in this case, Azure OpenAI, with your app, and you send a prompt and you get a prompt response. And that's great for a lot of use cases, but often we want to have a look at something called RAG apps, or Retrieval Augmented Generation. What that means in short is that you want the ability to speak to your own data, to search your own data. And for that to be possible, your data, first off, you need to identify which part of your data should be searchable, and then you need to turn it into a vectorized form, and then it's ready for search. To do all that heavy lifting for you, we are recommending Azure AI Search, and for storing all that vectorized content, we are recommending Azure Cosmos DB, and of course, Azure OpenAI as a service. And for your PDFs, for your Word files, CSV files, all that static content, we are recommending Azure Blob Storage. Now, thirdly, you might have a bit more advanced AI app, so-called an assistant, or a simple type of agent. But agents can also be very complicated. They could be goal-oriented and very autonomous. But what happens here is that we combine the skills of different AI apps. So we give them the capability to run functions on our behalf, to do RAG, Retrieval Augmented Generation. And for all of that, we're gonna, in the cloud, use Azure AI Search, Azure Cosmos DB, Azure Blob Storage, Azure Functions maybe even, and some kind of agent-based framework. So you can see how there are different use cases. So find those services that you need for your use case. Now, taking your AI to production, that's a very interesting conversation to have. So first off, you want to deploy your solution to the cloud. So getting from local environment to the cloud, that's a great win. But we think by using the Azure Developer CLI, we are making this an almost frictionless experience for you by you deploying an entire solution. And then we want you to have a think. What about architecture? Because what architecture you select kind of also gear what services that you can use with it. But the good news is that most services can be combined with each other. But the choices you essentially have here is a serverless-based platform or a container-based one. And for those of you who don't know what serverless is, think about it as code running for a reason, or event-driven architecture. Something interesting happens, so therefore some piece of code should run, and maybe it should trigger an event in turn. Now, container-based is fascinating. If you haven't heard about containers, the idea is that you have a programmatic, lightweight environment in which you say, in this environment, in this black box, I decide exactly what frameworks, what libraries goes in there, what environment variables, how to build, how to run my app. And the good news with containers is that it's most likely going to have the same kind of behavior even in production. So containers are a great way to ensure a very common experience throughout. So you don't have any bad surprises once you deploy. Lastly, we want to cover monitoring, scaling, and protecting your APIs, because ultimately you are doing this as a business, right? Which means you want security. Our recommendation here is managed identity over API keys. API keys are great to start out with, but they have problems around them, like having a very fine-grained experience with different roles, admins, normal users, somewhere in between. You don't have the same level of control, and it takes a while to replace API keys if you want to change them for whatever reason. So please consider managed identity, where Azure manages identity and access for you. Then we also want to talk about scale, how to load balance, because we know as more and more users use your app, congratulations, you are a success. You still need to consider load balancing to make sure that the load is even throughout all of your endpoints. And then, unfortunately, we need to plan for being resilient. And that means that we need to plan for errors happening. So we have patterns like short circuit, where we can just say it to a resource, hey, you're on a timeout. I'm not going to speak to you for the next 15 minutes. Meanwhile, speak to all of these endpoints instead. So this would then give the erroneous endpoint a chance to recover. And then once it's playing well, it can be let back in to support your users. Lastly, let's talk about monitoring. For putting things in production is great, but you need to be on top of things. So you need to monitor logs. You need to check token usage, not only for fair usage among your apps, but also that you are not overspending what you have in mind. Let's talk about tooling. We mentioned tooling initially, but what Azure Developer CLI or ACD is here to do is to make you faster, to accelerate the process in which you go from your local environment to Azure. So Azure Developer CLI is an open source CLI tool. That means it runs in the command line, and it helps you deploy an entire solution, front end, back end, storage, the works. And what it provides you is a developer-friendly environment with some great commands, but also support within your terminal, your editor, your integrated development environment, and for CI/CD. Having a look at the workflow, how this works. So imagine now that you have opened your terminal window. The first thing we want you to do is to run ACD init. This will help scaffold your project. So you're going to be asked some questions around what is your project, and then it will kind of create infrastructure files for you. The next step we want you to take once you do that ACD init, which you do once per project, then you do ACD up, and this is to package, provision, and then end up deploying the app. And then lastly, we want you to do ACD deploy and you would run ACD deploy to update your code, update your infra, and then quickly deploy those changes so you can see that live in production. So this is how you can definitely get started with ACD. So before you do anything else, we highly recommend you to go to the template library here that we have shown a link for. The idea is for you to search for what you want, what you need. Maybe you're running a Python app, maybe you're running something .NET. I'm positively convinced that we have a template that's already been created for you, so you can get started in minutes. So go to this template library, search for what you want, and you can see here on your bottom left side how we have the ACD init command where we use the -t for template, and you simply select the template that you want, and it ends up scaffolding that product for you. So definitely leverage our template library before you start doing things from scratch. What about architecture? Let's talk about architecture. Let's talk about the fact that we have two different choices and we just need to decide on one of them. On the one hand, you have the event-driven idea that code runs for a reason because something happens. For example, you as a company, you get a new customer, and most likely that's an important business event that leads to maybe an insertion in a database. maybe someone being sent an email, maybe you can just imagine the triggering of a lot of different operations. Azure Functions has a role to play here to carry out a lot of these tasks for you. And it's also part of the backend with Azure Static Apps. So that's also worth remembering. Then you have container-based on the other hand. As I mentioned before, containers are these lightweight black boxes that ensures that the environment looks the same in development as well as in production. They're fantastic, but you can also scale them in the millions. So you might have a few hundred users, but now you want users in the millions, and you might use something like Azure Kubernetes Service or Azure Container Apps to take you there. So let's talk a little bit about serverless now with Azure Functions. Now that we mentioned what serverless is, it's event-driven and Azure Functions has a role to play. Let's talk high level about the crucial concepts that you need to know about. Well, the trigger is important because the trigger defines when something should happen. So maybe someone uploads to a blob storage, maybe someone places a message in a queue, maybe there's a web request, or maybe time has elapsed. That's your triggering event. And so we have different triggers for you. And then there's also the notion of bindings. And bindings is code written to communicate with something on Azure. And this is code you don't need to write. So the idea with a binding is to make it super simple to insert into a database or create a message in a queue and so on. So define which trigger you want, but then leverage the bindings to make it super fast to write that code. But you could also combine products. So you could, for example, combine Azure Functions with Azure Container Apps. So it's not just used in one context. Looking here on the bottom right side, you see a scenario that I've been mentioning so far, but now you see it a bit more visually. So imagine now that this scenario kicks off when a user uploads a file to a blob storage in the cloud. What happens then is that this is a triggering event. So you have an Azure function that now runs that looks at the file that was inserted, and it validates its content, it processes the data, and it ends up maybe putting this in a message queue, or maybe it ends up triggering an email in turn. The point is something important happened and an Azure function responded. Let's talk about Azure Static Apps because that's an excellent choice. So imagine now that you're starting out very simple. You have an index.html file, that's all you have. You just want to deploy that on Azure. Azure Static Apps is fantastic for those simpler scenarios in the beginning. But as your app starts to flesh out, as you start to have more pages, maybe a backend, maybe you want to secure it, Azure Static Apps is still here for you. So imagine that progressive adding a feature and Azure Static Apps is there for you, then you get the idea. But one of the great features about Azure Static Apps is also the fact that it sets up your developer workflow. So imagine the first time you are deploying using Azure Static Apps, it actually sends up a CI/CD pipeline for you using GitHub Actions. So imagine now that you have done this once, you have your application in the cloud, and next time you do a change, you do so with a pull request in GitHub, and you end up merging that to your main branch. Now Azure Static App picks up on that change and ends up redeploying that. So imagine that. You do the first interaction with Azure, then you forget all about Azure, and then you just manage Git and GitHub, and that's how you want it as a developer. So great experience for developers for sure. So let's have a look at the features here also on the right side. And you can see that you're getting global hosting, you're getting API functions with Azure Functions as your backend, you are getting a streamlined build and deployment, and you also have different environments. And we all know how great that can be to have a staging environment, a production environment, so you can test things before your end customer sees it. And as I mentioned before, the CI/CD is set up that very first time that you deploy. I also want to get your attention on this one. Azure Function can actually be combined with Azure OpenAI. And if you remember what I said about Azure Functions and Serverless, we had the notion of triggers, why something happened, and binding, code that makes it easy to interact with other things that you can combine with Azure Functions. You can see here how it can do a lot of things for you. So here you have input bindings, you have triggers if an assistant does something, and so on, or maybe if you do something with an embedding when you're making your content searchable. So you can see how this doesn't have to be hard. Combining Azure Functions and Azure OpenAI, I would argue, is being made a lot easier by these triggers and bindings existing. So check those out if you're interested in that combination. Moving forward, let's talk about Azure Container Apps. Azure Container Apps is a great solution if you are considering a container-based approach. It is a serverless platform, so you maintain less infrastructure, you save a lot of costs while you run container-based apps, and who doesn't want to save costs in the cloud? This is great to use for API endpoints, for background processing jobs, for event-driven processing, for microservices. And if you look at the platform itself here on our right side, we see that you have automatic scaling, and it scales up or down depending on various scenarios happening. So maybe there's an increase or decrease in traffic, then it scales to fit, or there's some event that happens that enables it to scale up or down, or maybe there's some CPU or memory load, in which case it will also say, okay, I'll create more resources to meet the demands of the users. And it supports continuous deployment, code push, app deploy, and a lot of other goodness, as you can see. And it also integrates with Dapper. So if you're all into microservices, specified services that are good at really one thing, you get a very rich programming model thanks to this integration. So you get observability. Who doesn't want to observe your app, right? PubSub, you get service to service, retries, and much, much more. So this is really a rich experience. And as with anything container-based, you can really choose what runtime you want to run on it. So choose your programming language, choose your development stack, and use what you need with Azure Container Apps. So currently we are limited to Linux-based container images, but bring your Linux, bring your Windows to the cloud. We don't care, just use the cloud. So let's talk about our last chapter as part of this presentation: how to scale, how to monitor, and how to protect your app. So if we're looking here at Azure API management, it's a so-called turnkey solution, which means it's a great solution once you publish a few APIs or quite a few APIs and you want to manage that towards external and internal customers. This is a solution that kind of works for you. So the idea is to have a gateway in place between the user request and your end API. And within this gateway, we can define various policies to make it easier for you to say that this person should have access, this person shouldn't have access, and so on. And you can really manage groups really, really, really well. And you have this sense of end-to-end management as well. So you can use managed identity, you can make things scalable, it's a reliable way of publishing and consuming. And yeah, it's really great end-to-end experience once you start having a few APIs to manage. What's good to know though is the context in which Azure API management shines really well, and that context is AI. So it's a great companion service. So imagine now that you have provisioned Azure OpenAI. Our best recommendation here is that you put Azure API management in front of that. And why is that? Well, it comes loaded with a lot of policies that will make life easier for you. So for example, you got token limit policy, which means that you can ensure that not one of your application takes all the resources, but you can say, hey, you over there, you get 25% or N number of tokens, and that's all you get in this time window. So then you can ensure that other applications trying to use that same Azure OpenAI resource, that there are tokens ready and available for them. But of course, you want to measure all this, right? You want to measure what goes on, probably show that in a dashboard. And this is where emit token metric policy comes in. It's really great at collecting all those metrics, how things are being used, what application are using it, what user is using it, and so on. So you can have a really nice overview of the situation about how AI is being used within your apps. And then you got something called load balancer and circuit breaker. Now, load balancer is great because this ensures that you can always make sure that the end user has access to that API or access to that backend. And the circuit breaker makes sure that your app is acting like a resilient app, so there's no outages that affects the end user experience, but you seamlessly make sure to point your user towards a working backend because you're going to have more than one. And then you have a notion of semantic caching policy. And this can greatly improve not only your cost, but your performance, because if you have a lot of similar requests going through from a user or users, then you can instead respond with some cache response. And yeah, that could greatly speed up the end user experience, not to mention be very easy on your cost management. So we have come to the point where it's time to kind of sum up the whole situation. So what are we saying? We are saying Azure Developer Tools, ACD, Azure Developer CLI is our best recommendation for deploying whole solutions. We think that you will select between a serverless architecture involving Azure Static Web Apps or Azure Functions, and or a container-based one with Azure Container Apps, because as I mentioned, Azure Functions and Azure Container Apps could definitely be combined. But now you have a mental model of those two different options. And what we said here last about API management, once you put Azure OpenAI in production, we really recommend that you put API management, or APIM as it's also known, in front of it. Enable all those policies meant for Azure OpenAI to make sure that it's secure, that it scales, that you keep track of cost and usage in production. Thanks for watching. My name is Chris Noring, and stay tuned.